Okay, let's go ahead and look at this problem. I'm just going to put mine on the overhead so it'll be on the video. As I look around the room, I see that everyone did this correctly, and the only consistent error I see is lack of attention to sig figs. So if we draw this, we have carbon monoxide, which has a carbon-oxygen triple bond, and I have 2 moles of that. Oxygen gas has a double bond, 1 mole. 2 carbon dioxide, so we get 4 of those carbon-oxygen double bonds in CO2. And we can get the numbers from the chart. So my enthalpy of formation is equal to 2 moles times 1,070 kilojoules per mole. 1 mole times 498.7 kilojoules per mole, 4 moles times 799. And when we go to add these all up, the place that sig figs get controlled is right here because we have 1,070 and the last significant digit is in the tens. So we carry that here and we get negative 560 kilojoules. And I saw people going out to the tenths place because that's what your calculator did. So just pay attention to sig figs. Think about it, that costs you half a point on every problem, okay? It's a 10% deduction. So that gets you from that A you're shooting for 10% down to kind of the lower part of the range. All right, any questions on this? Okay, now we're going to look at the very last concept in Chapter 10. This is one more way to calculate enthalpies, and I think this is the most confusing one. So when you look at this, this may be sort of a memorizing exercise for some of you where you just say, I got to add all these numbers up. And maybe some of you will find this easier if you think about it in steps, sort of a practical thing. So calculate the lattice energy for the formation of sodium chloride. Well, when we think about sodium chloride, we think about making sodium ions that react with chloride ions and they make sodium chloride solid. That's how we think about it getting prepared. But if we think about where do I get sodium ions, we can look at a lot of definitions about ionization energies, atomization energies, and lattice energies. So if we think about this in steps, we are asked here to find the lattice energy for the formation of sodium chloride, and we know the enthalpy of formation. So we have to think about this overall reaction. We say the enthalpy of formation is equal to all of the atomization energies. Atomization energies are taking something in its natural state and turning it into gaseous atoms. Then ionization energies. That's the energy to make a cation. So this is to make the cation, the positive ion. This is for all elements, whatever we have to start with on the left side. The electron affinity is the energy to make the anion. And the lattice energy combines the ions to make the compound. Sure. So when we look at these, we say, okay, the enthalpy of formation is equal to all these energies all added together. Some of these are positive, some of them are negative. We just add them all up. So we have to think about the atomization of sodium. Sodium in its natural state is a solid. When we atomize it, we make sodium gas, and that's the atomization energy. And this is a positive 107.7 kilojoules per mole. Then we have to form the sodium ion. That's the ionization energy. So my gaseous sodium atom can give up an electron to make a sodium ion in the gaseous state plus 1 electron. And that takes energy. It's a positive energy, 495.9 kilojoules per mole. Now we'll think about the chlorine. I have chlorine, and that gets atomized. So it takes a half a mole of chlorine gas to break apart and give 1 mole of chlorine atoms in the gaseous state. That's the atomization energy for chlorine, and that is a positive 121.7 kilojoules per mole. Then we have the formation of the chlorine ion, the chloride ion, and that is where the chlorine atom grabs the electron that sodium gave away to become chloride. And this is the first negative energy. When the chlorine atom gets an electron, we release energy, negative 349 kilojoules per mole. Then the sodium ion and the chloride ion come together and they make sodium chloride. And this is the ionization or the lattice energy. And that is our unknown in this problem. So if we look at this and we think, okay, for any reaction, the enthalpy of formation is equal to the atomization energies plus the ionization energy plus the electron affinity plus the lattice energy. All I'm trying to do in this problem is solve for the unknown variable, which in this case is lattice energy. So I can rearrange this. We know delta H0 sub F is AE plus IE plus EA plus LE, alphabet soup, right? So I can rearrange delta H0 sub F minus the atomization energies minus the ionization energies minus the electron affinities is equal to the lattice energy. And that's what I'm trying to solve for. So in this case, all I need to do now is plug in the numbers. My standard enthalpy of formation was provided. I'm making 1 mole of sodium chloride, and it's negative 410.9 kilojoules per mole. That's my delta H0 sub F. Minus the atomization energy for sodium. Minus 1 mole times 107.7 kilojoules per mole. That's the atomization energy for sodium. Minus the atomization energy for chlorine. 1 mole times 121.7 kilojoules per mole. So that's the atomization energy for chlorine. Minus the ionization energy for chlorine. Or for sodium, sorry. Ionization energy is making a cation. So minus the ionization energy, 1 mole times 495.9. I'm running out of room, so I'm not going to write the kilojoules per mole, but no, it's there. So now I've subtracted out the ionization energy minus the electron affinity, 1 mole times a negative 349 kilojoules per mole. And all of that is equal to my lattice energy. So all I'm doing is addition here. It's just sorting through the alphabet soup to find out what these numbers represent that takes the time. So I get negative 410.9 kilojoules minus 107.7 kilojoules minus 121.7 kilojoules minus 495.9 kilojoules plus 349 kilojoules is equal to my lattice energy. So I get negative 787 kilojoules is equal to the lattice energy. So all I did was work with that equation at the top of the page where the delta H0 sub F is equal to the atomization energies plus the ionization energies plus the electron affinities plus the lattice energy. I just added them all up. and I solved for the missing variable. Now, if I had been given all the atomizations, ionizations, electron affinities, and lattice energy, I could find the delta H. You can find any variable that's missing. Okay, in the interest of time, I am going to stop here. There is one for you to practice on the next page. I'm just going to let you practice that at home. And the answer for this problem, lattice energy, is negative 808 kilojoules. Hopefully you can use that. You'll do this problem at home, and you can use that to check if you got the correct answer. I think it's pretty straightforward. And when you're doing this at home, you will just start again by looking at this equation at the top of the previous page and plug in and solve for the missing variable. Yeah, you should know that. Okay, so just think of it. The question was, do we have to memorize that equation? And I don't think of it as memorizing. I think of the heat as making atoms, making ions, adding them together. So, and if you were to encounter a problem that had all of this stuff listed, I think it would be more obvious what you were supposed to add up, that you wouldn't feel like, oh my gosh, how do I remember all those numbers? I think it would be pretty obvious how to do that with all that written in front of you. Yes? I hope? Okay. So that wraps up